So this is our example of calling assembly module procedure from C++. I'm now going to just close all of these views and go back to my Solution Explorer. And I'm going to delete these files because we're going to switch over to our next demo. But before I do that, I've saved the two modules here under source_copy string. So these are no longer included in our project directly, but you can use it for your reference. Okay, so I'm just jumping here and selecting here and just say exclude from project. Okay, so the files are excluded, and I'm going to go to source, and I'm actually going to delete these files. Just press the delete key to delete them and free up space for our next example. And our next example demonstrates invoking a C function from assembly. So let's use these download links to download our next sample, which is called COPYNEW, using COPYNEW as an example. So we're just going to save link as, and it's already remembering my location, so I'm just going to save all of these files right here. You see that as soon as I begin to save these links, the files appear in this area. So all of the files are now being downloaded, and notice that we have two C++ files, one assembly file and one C++ header file. All right, so when we put source files on the source list in our project configuration, so I'm just going to keep this in view like this, and right-click the source files and say add. Of course, add existing items because the files exist already. So click, and we're looking at the same place. So I'm going to press Control key down and click ASM, CPP, and CPP, but not .h. Okay, so just never include C++ header file on the list of source files. It's a wrong choice. It's just very poor choice because header files are not source files. They contain declarations of things, they contain definitions of constants and some other parts that typically go into the header file, but they are not source files and they're not intended to be compiled independently. They only are included in the project source files. So no to H. So I'm just going to add these three. Okay, so now they are appear here, ASM, CPP, CPP. And so this is our new sample to explore. So let's first take a look at the main file, right? So this is our main file. So what's happening here is that we include header file in this module right here. And again, we declare source, which is just a pointer to a constant string with the new line character. The destination, something that we call COPYNEW, and this is COPYNEW is a procedure that we invoke, and this procedure is defined in M13 ASM. COPYNEW. So let's take a look at this. I'm just going to maximize my view, double click the ASM file, and move it to the next tab right here. So we can continue to explore. So this COPYNEW, this is similar to what we did with copy string, but this is something COPYNEW. So we pass the source as a parameter. Of course, this is a pointer to a string of characters. And COPYNEW is a public procedure defined in our assembly module ASM, COPYNEW. And it takes string as a parameter. And so what we do here, we are using a technique that we already discussed when we were talking about calling C standard library functions from assembly module. And so because we know that we're part of what is being compiled by C++ compiler, of course functions like strlen are available when we start to include C and C++ standard library headers. So so what we do here, we're going to calculate the size of this string right here. Then we're going to call procedure name new array. And new array, of course, strlen is part of the C standard library. So we call that. And then we also call new array at 4. So new array at 4 is actually a procedure that is defined in C++. And this is our example. This is the current idea that we're going to demonstrate how to write function using a C calling convention and make a call into this function from assembly module. So this is where we make a call. So first of all, this function is declared in this header file. So if we just drag and drop this here, this is our header file. Let's move move it to the previous side right here. So new array at 4. So new array is declared in new array.h in the header file as a standard call. So this is still standard calling convention. So all we need to do is just prepare the argument on the stack and make a call. There is no need to maintain the stack because standard calling convention specifies it's actually the callee, this function supposed to take care of it. And it takes size. This is just a positive integer. Size t is a positive integer. So this is the input parameter for new array. So we have these two declarations, and of course, once again, COPYNEW defined by assembly module also needs to be accessible in C++. So we're keeping two of these declarations together in this header file, which we can now include in any of our C++ modules. So finally, this function is defined in new array.cpp. So I'll just move it to new vertical group right here, and it's really quite simple. So this new array, when we make a call into it, so this new array looks like basically taking the size and using C++ new operator, which allocates space, block of characters on the free store or a heap memory. It's like dynamically allocated memory. So the new operator in C++ is responsible for allocating new memory. And we say that we would like to have this many characters, block of this many characters. And so this is what we do, and apparently this size is prepared in register EAX, and then we push it on the stack, and so this variable will be initialized with whatever value comes from here just before we make a call. Of course, a very important observation is that we try to decorate the name with @4, because when we use standard calling convention, when we're going from assembly module to C, this is not automatic. This part has to be added by us manually, because we know that standard calling convention will produce this type of suffix, and we just have to add this manually. In other words, we need to examine this the signature of this function, realize how many bytes it's expecting as an input, and we need to add this manually right here. If we forget, then we get a linker error when we're making this call from assembly into this program. So that's pretty much all the source code that's available here, and of course the logic of this is very similar. So basically what happens is that as we enter procedure, we preserve ESI and EDI, make sure that we preserve these two registers without disturbing the stack, because perhaps when we're making this call, C++ compiler is not expecting these two registers to be modified. So this we have to preserve them, and we preserve the pointer. We call, we just push pointer to the string of characters right here to stack and call strlen. It returns register EAX, the length of the string, right? So the length of the string will be returned in register EAX right here, but we increment EAX in order to account for zero terminating character, and then call new array, so that when we call this function named new array, we reserve space not only for the characters in our initial string, but also null terminating character. So this will allocate new block of memory, but we're not doing this here in assembly. We're calling a C function to do this right here. And then it's exactly the same as it was before. We create a loop and we copy all the characters over, and we just return back with pointer to dynamic memory. So the pointer to dynamic memory that we've got from new array, of course, by the way, this return, right, returns pointer to the block of characters, and we get it in register EAX. So we preserve this, again pushing it on the stack, and just before we return, we restore it into the register EAX. And this is how destination will get this here from register EAX. And at this stage we have new characters in place, and we display the new characters, but this time copy of the string is allocated dynamically, not by reserving space at compile time, but asking C++ compiler to provide us with dynamic memory that can be done with the new operator in C++. So this here is the call from assembly module into C++ program that provides this function with all required decorations, and everything needs to be in place correctly. And notice that the return type of this function is pointer to character, right? So when we call new, it returns brand new block of memory of this size, and new returns a pointer to that memory. So we return it as this, and of course we get it inside register EAX upon return from new array. And we also initialize our destination with the same value, so that the copying is directed to this newly allocated block of characters.